Desha.
And then,
So we're here to talk about the application of exponential functions.
namely, the exponential growth, exponential decay, Newton's law of cooling, decibel scale, and the Richter scale.
But now we're gonna give you 3 equation examples.
Exponential growth. Exponential growth is exhibited when the growth rate of the value of a mathematical function is proportional to the function's current value, resulting in its growth with time being an exponential function, a function in which the time value is the exponent. Irene deposited $80 in a savings account, earning 10% interest compounded annually to the nearest cent. How much will she have in 3 years? The given values x equals 1 year, y of t is equals 10% of 80 plus 80 is equals to 88%, a is equals to $60. Y of t is equals AE to the power of k. Y of t is equal to AE raised to the power of 80. Substitute the given values of 88 is equal to 88 raised to the power of k. Divide both sides by 18. Then it becomes 1.1 is equal to e raised to the power of k. We use ln on both sides, and we apply power law on the right side of the equation. We then cancel ln e because it is equal to 1, so we have the value of k which is 1.1.
And then, substitute the given values to the equation. Y of t is equal to 80e raised to the power of ln e 1.1 times 3. So ln 1.1 times 3 is equal to 0.286. E raised to the power of 0.286 is equal to 1.331 times 80, which is 106.48. Therefore, Irene will have $106 in 3 years.
Exponential decay. If subject to exponential decay, if it is decreases at a rate proportional to its current value. Here I have one example of a problem on exponential decay. Jose bought a brand new pickup worth 1.2 million pesos. Every year, the value of the pickup depreciates at 15%. Before we answer the problem, we're going to get the value of k. In solving the value of k, we use the formula y of t is equal to AA raised to the power of kt. In order to find the value of k, we use the following data. Y of t is the depreciated amount. A is the previous initial amount. T is the time. K is a growth constant. Given. T is equal to 1. Y of t is equal to 1.2 million minus 15% times 1.2 million. Y of t is equals to 1.2 million minus 180,000. T is equal to 1. I know. Shoot the following values to the formula. 1,020,000 is equal to 1,200,000 times e to the power of k. We divide the whole equation by 1,200,000. So we have 17 over 20. So we have 17 over 20 is equal to e raised to the power of k. We use ln on both sides of the equation. Ln 17 over 20 is equal to ln e raised to the power of k, then apply the power rule. On the right side, of the equation, ln E is equal to 1. So we cancel ln E. Y of 5 is equal to 1,200,000 E raised to the power of 0.8125. Y of 5 is equal to 1,200,000 times 0.4437. Therefore, the pickup truck will cost 532,446.375.
What's up? For now, we will talk about the Newton's law of cooling, which states that the rate of heat loss of a body is directly proportional to the difference in the temperature between the body and its surroundings, provided the temperature difference is small and the nature of radiating surface remains the same. For example, this problem. A pot of soap starts at a temperature of 373 Kelvin. If the cooling constant is K is equals to 0.00151 per second, what will the temperature of the pot of soap be after 20 minutes? A note, the surrounding temperature is 293 Kelvin. So first, we will plot the given. Time should be in seconds. So 20 minutes is equal to 1,200 seconds, which we get from multiplying the 20 minutes to 60 seconds over minute. Then the surrounding temperature to the 293 Kelvin here. Then the object temperature, which is the 373 Kelvin, and the cooling constant, which is the 0.00150. Then the formula. So the formula is equals to the surrounding temperature plus the quantity of the object temperature minus the surrounding temperature times E, which is raised to negative K times T, which is the time. Then substitute the values. The time, which is 1,200 seconds, is equals to the 293 Kelvin. 293 plus the quantity of the object temperature, 373 minus 293. Then the E raised to negative K, we will negative it. Negative 0.0015150 times the 1,200. Then, by the rule of PEMDAS, we will execute first what is in the paragraph. Inside the parenthesis, I mean. Okay, so T 1,200 is equals to 293 plus subtract this. So this is equals to 80. 80. Then next is this first multiply it, negative 0.00150 times 120 is equals to negative 1.8. Then second, by rule of PEMDAS, multiply the exponent. So the E raised to E negative 1.8 I mean is equals to 0.16 dot. Okay, next by the PEMDAS multiplication, then is 293. We will multiply this times 80 is 13.22 dot. Then we will add the 2, so plus 293, it is 306.2239111. Then we will round up to the nearest 100, so is 306.22. Don't forget the Kelvin. So therefore